Hello everyone, welcome to the video explanation for Brian Passwater's topic 315 notes, example 6. Example 6 says the figure shows the graph of the polar function r equals f of theta, where f of theta equals 3 times the sine of 2 theta for the interval 0 to 2 pi radians in the polar coordinate system. Which of the following intervals is the average rate of change of f of theta equal to 0? So essentially what we're trying to do here is we're trying to figure out when our a rock would be equal to 0. Well, that happens anytime that f of b is equal to f of a. So what we're looking for is on which of these four intervals are the outputs for a and b the same. Because if the outputs are the same, then the top of our a rock fraction would be equal to 0, meaning that the rate of change would be equal to 0. So the tricky part here is that these polar coordinate graphs can be somewhat hard to read. So the approach that I'm going to take is there's only four numbers here that need to be plugged into the function: pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And I'm going to plug those in because that will allow me to label those points on the graph, and then I can quickly use those to figure out which of those intervals, A, B, C, or D, those answer choices, which of those intervals has an a rock of 0. So essentially what I'm going to do is I'm going to plug each of the angles into the function. So f of pi over 4 is 3 times the sine of 2 times pi over 4, which would be 3 times the sine of pi over 2. The sine of pi over 2 is equal to 1, so that output would be 3. What that tells me is that this point right here, which is at pi over 4, has the coordinates r at theta 3 times 3 pi over 4, right? So when I feed pi over 4 in, I get 3 out. I'm going to continue to do that for these others as well. So 3 pi over 4 is the next interval endpoint. 3 times the sine of 2 times 3 pi over 4 would be 3 times the sine of 3 pi over 2 would be 3 times -1, or -3. Now that's significant because that means that that point is actually located in quadrant 4, because the angle 3 pi over 4 is here, but if the radius is negative, it's a signed radius. So that tells us to go out the other direction, which means that this point down here is the 3 pi over 4 point at -3. We're going to continue this process, so next would be 5 pi over 4, which again is 3 times the sine of 2 times 5 pi over 4, which would be 3 times the sine of 5 pi over 2, which is 3 times the sine of pi over 2, because 5 pi over 2 and pi over 2 are coterminal, which would be 3 times 1, or 3 again. So that's this point down here is 5 pi over 4. And then if I do that one more time for 7 pi over 4, that's 3 times the sine of 2 times 7 pi over 4, which is 3 times the sine of 7 pi over 2, which is 3 times the sine of 3 pi over 2, because 7 pi over 2 and 3 pi over 2 are coterminal, which means again I'm looking at 3 times -1, or an output of -3. So that would be this point here, would be -3 7 pi over 4. Now, why is this significant? This is significant because that allows me to look at my answer choices and know, well, which one of them has the same output for both values. For instance, pi over 4, which we see here and here, has an output of 3. Okay, so that's telling us that f of a is 3 for those two. Okay, and then 3 pi over 4, which we see in a couple places, 3 places, it has an output of -3. So in that case, this would be f of b equals -3. Those are not the same. Okay, f of a does not equal f of b. which means the rate of change is not equal to 0. Okay, all we're looking for is where these are the same. So here this would have our f of a equal to -3 for both of these, because that's the output for 3 pi over 4. 7 pi, or 5 pi over 4, we see here only. 5 pi over 4 has an output of 3. So there we have f of b is equal to 3, meaning that f of a does not equal f of b for option B, which means the A rock does not equal 0. So B is not the correct answer. And then finally, we're looking at 7 pi over 4, which is -3. So that means the correct answer, where f of a is equal to f of b, is answer choice C. Because if those are equal, the A rock is equal to 0. And again on D, f of a does not equal f of b, which means the A rock does not equal 0. So that's all we have to do. We have to figure out which of these points are which on the graph. Remember that polar graphs are kind of tricky. In this case, if we follow the graph as we put in the values to the function, it's going to graph itself without being able to pick up the pen, and I actually already screwed that up. Okay, it's going to go around, and then it's going to go into quadrant 3, and then it's going to finish in quadrant 2, because when we pass through 2 and 4, those R values are negative, which means we're really switching those coordinates around. You should be able to graph the entire polar graph without picking up your pen, which can be very tricky. So another option is to plug each of your interval values into the function, get the outputs, and then you just have to look at the outputs. Where does f of a equal f of b? Because then where f of a is equal to f of b, the A rock is equal to 0. That does it for this one.